they're in your brain, and then being able to think about those and make those connections. So I think everybody has the ability to problem solve, but sometimes it's a little bit about turning the problem on its edge or on its side so that you can make those connections to be able to find those solutions and think about things differently. So today I want to equip you with different ways of thinking about things so that as you approach your own projects, you can think about things in a different light that you might not have thought about. And a lot of these exercises provide you with those tools for being able to turn problems on their edge. So I'm just going to kind of walk through these different things. So every idea and every concept comes with a vision. What are we actually doing? So when you look at Learn with Redwood, what are we actually doing? Well, we're providing the ability to help somebody learn how to be a full stack developer through the lens of Redwood. What is the mission there? It's about helping level up developers and giving them an edge. It's about helping them further their career and becoming better at the work that they do. And so what's the goal? Well, in this case, it was all about creating a course that would help people be able to do that. And how are we measuring success? Well, a lot of it is how many people are we able to help further their career? How many people not only purchase the course, but also work through it and become better developers and create better applications? Because it's not just about coding, right? It's about the applications and the things that we are able to build in order to change the world. So once you have that why, once you have that vision for your product or whatever you're working on, what do you do with it? Well, maybe you've seen this before. This is a pretty popular canvas or grid that people will work through as they're trying to develop a business. So you take the problem that you're working on and you determine what activities and key resources that your product is going to offer that other people don't. That goes into your value propositions. You also talk about the customers that you want to influence and the relationships that you want to develop. You talk about different channels. How will we distribute this? How will we market it and promote it? What are those customer segments that we're going to try and influence? And then, of course, if you're trying to build a business, you're going to need cost structures and revenue streams. So thinking about these things and being able to flesh them out, get ideas out of your brain and onto paper. So once you have those things, one of my favorite tools for being able to work through not only a marketing plan and how you talk about your business, but what is the problem that your application is trying to solve? So this is a popular model that was developed by Don Miller. He has a brand called Story Brand. And what he does is he talks about how a lot of the things in movies and film talk about what makes up a good story. And so when you're working on your product, you want to incorporate those same principles in the work that you're doing. So you always have a character, and the character is not you. It's not even your product. The character is the person that you're trying to reach. They are the main character. They are the ones that have a problem. They meet a guide. So hopefully that guide is you and your application. And you're able to give them a plan to be able to solve something. You're able to help push them towards an action. And it always ends, or hopefully always ends, in success and helping them avoid failure. So at the end of this entire journey, there is a character transformation. And so you want your marketing materials and the way that you talk about your product or your whatever you're offering to help move somebody through that entire process. So one of the things that we've done at Zeal is we're helping companies work on their products and their applications. We help them try and think through a lot of these different tools that we're talking about today. I wanted to show you a couple examples too. So one of the things that we do is we work through a user persona. So we talk about, okay, who are the key people that we're trying to reach? And so we talk about their biographical information. We talk about their goals and their needs and their pain points and whatever the most important task is. So this is for an application that we were building where we really had 3 different groups of people. We had a mentor that's trying to work through it. And this mentor is coming at it from a professional skills perspective. They're trying to help somebody level up their career through their, I don't want to use soft skills, but it really is professional skills. Then we have another mentor that's approaching it from a technical skills perspective. So they're also bringing these mentor opportunities to the table, but they're approaching it in a different light. So those are 2 different personas. Then we actually have someone that's trying to work through the program. So they're going to have a different set of problems that they're trying to encounter. And so whenever you're building your application, you want to think through how each of these users are going to be using your application. So one of the things that we did was we filled out the user personas, but then we also did interviews and we talked to different people about how they were using their current setup that they had. So we had built out the application really in Notion and tried to see where are the edges in our current system, and then how do we apply those things to an actual application. So we did interviews talking about what their goals and their needs are. And you can see all of that cataloged here through tons and tons of digital stickies and Post-its. But then what we did was we tried to group these things. So looking at their goals and their pain points and how Notion filled these things or different tasks, and grouping these allowed us to determine what those patterns are so that we could help build the application in a way that made sense. But doing this, it's sometimes hard when you have somebody's stream of consciousness. It's hard to know exactly what feature you're trying to build until you start to group these and look at the problem on different angles that we were talking about. Another tool that we use is finding parallels. So this is a really fun concept that I enjoy working with. It always shines a light on things in a new and different way. So one thing that you can do is look at onboarding. So recently I was looking at the application Linear. I was very impressed with their entire onboarding experience and how it guides you through. It's very well designed and very well thought out. So if you were to look at that and outline all the steps that they went through, if they were trying to improve their process, they're listing out all the things that they do. And then you take something completely unrelated. So my family recently went on a Disney cruise, and their experience is phenomenal in just what they're able to offer families. So if you look at all those things, and that is a not totally, but mostly an offline experience. When you arrive at your port of call, what does that look like? How do they guide you through the queue line? How do they get you excited about what you're going to do? How do they get all the information that they need, like your passport? What are the bands and the bracelets and that entire process? What does that look like? So then once you take those things and you look at, okay, what makes this an excellent experience? And then you mash it up against, say, your onboarding experience. So when you have those mashups, what does that look like for your application? So let me give you a different example that's not a Disney cruise. If you are a Hilton member and go to a DoubleTree, one of the things that they offer is chocolate chip cookies when you come into the lobby. So the lobby smells fantastic. You're greeted and you sign into the hotel. They give you a chocolate chip cookie. That's a fantastic experience and a great first impression. So how do you provide that experience of getting a chocolate chip cookie to your onboarding experience so that users are surprised and delighted by that entire experience? Let's look at some other things that we do. So another thing is creating a storyboard. So we went through this process as we were trying to build out an application where we had everybody that was involved in the building of the app that had a stake in it. And we talked about, okay, if we just take one thing, so as a mentor, I need to fill out a weekly evaluation. What does that process look like? And so everybody outlined what those steps are. And so this might be your story, your ticket that you're trying to work through, but how it actually gets fulfilled or how you reach that solution might look different based on the perspective that you bring to the table. There is a lot of overlap, but this also helped us narrow down and pare down exactly what features we needed to build and what that actually looked like when we actually put code to the problem. So another tool that we use is, this is starting to get more into the design side. This is a UI flow diagram. It looks pretty complicated, right? But the idea behind it is that with an application, there are so many different states and changes that are happening on the screen. So you might have a dashboard here, but this card and how it behaves will send you somewhere, or based on your interaction or the type of information that it's displaying will show up and behave differently. So one of the things that we like to do when we're designing is we create these UI flow diagrams where we show how is the information flowing through the application. And this helps us then create a checklist of all the things that we need to do in order to make the application happen. What are all the programming things? What are all the tickets that we need to write out? So one thing that I like to say is that design is cheap. And as a designer, that might be a little hurtful, but I can iterate so much faster here trying to design solutions than it would be to actually program that out and try and write out exactly in code how that's going to happen. So this is a great tool to be able to flesh out those ideas to be able to say, have you thought about this? Or when a user clicks on this, what's going to happen? And you're able to start defining those things beforehand. So another tool that we use is an application map. And so in this particular screen, you'll see that we will take sections of the app. So it looks very similar to a sitemap. You can see all the different pages that are within the application. But then we highlight, okay, have we written all of the issues for this particular page, for this particular feature to be finished? And then we also look at the design. Has the design been completed? And then we look at development and say, okay, where are we in the development process? So you can feel like an application is pretty far down the road, but that's a feeling that you have. And what this does is it allows you to communicate exactly how much of the application is finished. This is also perfect for stakeholders and helping them know, okay, how much of the application has been finished? What areas of the app haven't even been touched yet? How much left do we have in the roadmap? And so this has been a fantastic tool that we've used. I'm sure you guys have all seen this before, but I did want to highlight it in terms of visual thinking. This is incredibly helpful. So what this is doing is it's outlining, say, your database and all the relationships that might need to happen within your app. Just by drawing that out is a lot easier to be able to see the data that's in your app versus just writing out a list or writing out a schema file. And you can see how those relationships are working together. Okay, so let's talk about once you've actually started building features and you're trying to iterate on those things, what are some other visual design tools that you can use to be able to work through a specific problem? So this is a great one. This one is called What, So What, and Now What. So a lot of these exercises are best done with a team, but if you are a team of one, I still say that it's incredibly important to go through this exercise. So the first thing that you're going to list out is what. So what actually happened? What are you trying to accomplish? The second phase, you're saying, okay, why does it matter? Why is it important? And why should we focus on it? And then that third step, okay, what's next? So if you're looking at features, this is incredibly helpful. If you're looking at problems, this is also incredibly helpful. Another tool that we like to use is called Crazy Eights. So this is a grid of 8. And the idea here is that a lot of times your first idea might be a great idea, but what happens by the 8th idea? So if you keep iterating and come up with 8 different concepts, what does that look like? And so you're able to push your brain, your thoughts to come up with different solutions to see how you can push that problem and maybe come at it from a different perspective. This one is kind of similar to that what, so what, and now what, but you're also looking at the how. So not only what are you trying to accomplish, but how will you actually do that? And not only harping on maybe the problem, but how you're going to solve it and how you can make the situation better. In this particular tool, what you're doing is say you're looking at a proposed change or a product or a service, and then maybe things that would prevent it from adoption, and then being able to overcome that adoption. And so this helps you to look at a problem from different angles and maybe come up with solutions to help you overcome barriers before there are already issues or problems or whatever. I'm going to jump ahead to this one. This is probably one of my favorite tools. It's called Round Robin. And so what you do is, in this case, you have your participants that are helping you think through this, put their name at the top of the sticky, at the top of the column, and you put your problem statement or your challenge. So as we mentioned earlier, we were talking about an onboarding experience. So maybe there's a gap or a fall off in your onboarding flow that you want to address. So what you can do is you can say, okay, this is the problem that we're trying to solve for. And then you have each of your participants list out an idea to be able to solve or overcome that problem. And then if you follow your color, so if I'm participant 1 and my color is yellow, I'm going to then come down here and I'm going to critique participant 5's idea that they had. I'm going to try and poke as many holes in their idea and maybe say why it wouldn't work. And then in the next round, what you're going to do is you're going to still follow your color. You're going to look at participants for idea, critique, and then you're going to provide a solution for whatever that critique was. For whatever somebody poked a hole in, you're going to try and plug it. So this is great because not only are you throwing out ideas and talking about possible problems, but more importantly, you're coming up with the solutions behind those problems. So the last thing I wanted to talk about, and we'll kind of come back to the beginning here, is we, with Learn with Redwood, kind of moved beyond that design piece of it, but we talk about the actual implementation, that how and how you actually build the app and what that solution piece looks like. So I did want to highlight that. So check it out, learnwithredwood.com. The other thing I wanted to say is if you do want to follow me online, I am at Self Teach Me, most places. So feel free to look on YouTube, on Twitter. I would love to have a conversation with you, not only about Learn with Redwood, but about any visual thinking and situations that you might be trying to overcome. And then the last thing I wanted to highlight is if these tools and this toolkit is interesting to you, be sure to check out productshipkit.com. And I would love to send you some of more information about each of these tools and how you might be able to use them with your team. So David, thanks again for having me on. I really appreciate being able to talk about Learn with Redwood and also just the visual thinking that goes behind products.
Thank you, Amy. All right. I do want to, okay, that was a lot there. That was great. Thank you so much.
I would love to answer questions because I think you said the first 20 minutes is presentation, the next 10 is
questions. Well, no, exactly. So we have at least, we have about 7 minutes for discussion here, and we have the Redwood Core Team joining us. And we'll switch over to the second presentation. But first off, before we do questions, would you go back and share your screen? I want to highlight Learn with Redwood a little bit more here.
Yeah.
And tie the two things together, because all of one that was great and delightfully surprising in everything that you covered and what goes in behind the scenes, and then tying that into the Learn with Redwood. One, this is available right now, right? So you guys are beginning to release content. So what's the current status? And then again, this isn't just, so help me summarize, make sure I'm correct. Yeah. This isn't just hey, here's how to learn this library. Here's how to understand this technology. But really what you're taking people through is now the process of implementing. Once you have the concept, the story, once you've done the design, the front end, the design work that you just mentioned, then you come through and actually build out an application, but you're also learning all the tools and all the libraries along the way. That's right? That's right. Yeah.
Yes. And I want to be clear. We don't talk about necessarily, even though the presentation was about visual design thinking, we don't necessarily talk about that within the course. The course is more focused on that how piece, because once you solve the what, now you have to solve the how. And that's the part that people look at. And so this really does focus on removing that pain from the full stack development. So I wanted to pull up the actual website and just instead of just
I wanted you too. Thank you.
Yeah, okay, good. So these are all the topics that are covered. And what's interesting for me as I've developed the course material is that you're talking about that flow that you do for each feature development. So break that down just a little bit. A lot of courses that you'll work through, they'll say, okay, we're going to focus on the styling, and you'll do all the styling for the app. Then what you'll do is you'll say, okay, now we're actually going to hotwire this and connect it to the database, and you focus on all that. And then you're like, okay, maybe testing is an add-on. Maybe it's a bonus. It's not even included in the core concepts of the app. It's an afterthought. And so what happens in real life, if you're working on a real design team, is you don't work like that. Because if you do, then you have half-baked features, and it basically is going to take the entire project life cycle, like the entire product, for you to be able to get any results and get any feedback, because all along you have these half-baked ideas. And then testing is like a nice thing. So one of the things that I really do love about Redwood is that it encourages you to build with the best methods in practice. And so a true feature set when you're working on a team is you say, okay, this is the piece that we need to build. And so you'll do the design work, you'll do the testing, you'll build the components, you'll hotwire everything. You do all that, and then you release that feature and you're able to get feedback on that feature. And then you'll go on to the next feature. So you're constantly getting feedback, and your application is going to be so much better for that. Because at the end of that feature, you do have your storybook story, you have your test, you have everything to make that complete. And so that's what the course material does. And that's how it works. So if you come on down, I'll keep coming down to the material here. There's an intro section and setup, but then this whole storybook, it looks a little bit larger when you look at it in comparison to these other pieces, but we develop the entire portion of that feature so that as you move through, you are completing features just like you would on a true design team, or sorry, development team.
Well, this, yeah, design and development team.
Yeah,
Amy,
that's true.
thank you. That's really helpful. And it's so, you're right. It's so on the target for what Redwood is intended for.
Mhm.
When we like, the reason why Redwood seemed to stretch the boundaries of what you would include out of the box in a full stack framework was because it was so focused on process and
Mhm.
teams and being able to isolate different implementation processes, the front end, the back end, but not just the front end, right? You've got data structure in the front end, but you also have the design, what you're going to need to do testing. What about the back
That's right.
end? How's your data model flow across the entire
Yes.
application? And we were thinking all that. We've had a really hard time communicating that, but people, when they use Redwood and get it, they're like, oh, this ties it all together. And I just love that you get that. And of course you would. It should not be a
Yes.
surprise to me, but you say and speak to that so much more eloquently and accurately than I do. So thank you. And I love that that's how you modeled the Learn with Redwood course.
Yeah. So let me also just highlight, these are all the technologies. So when people are like, oh man, Redwood, another framework, there's so many to pick from. The beauty is it's really taking the best out of the entire JavaScript ecosystem and putting that all together. And I wouldn't say just, I mean, you have React, you have GraphQL, you have Prisma, Storybook, Jest, and TypeScript. And that's kind of what endeared me to Redwood to begin with. It was like, these are all the tools that I would choose anyways. And it's packaged everything up and made it so much easier to approach. So when you're talking about the course, you ask like, what's the status of it? Because if you look at it, it does say pre-access, I think. So what we've done is we have soft launched the course. You can buy it now and have access to the lessons that are available. And then we are doing Friday drops. So tomorrow there'll be a whole new set of videos that are available Friday following. So makes Fridays fun. So much for not launching on Friday. We were launching every Friday.
I think Rob created a website for that actually.
Good.
Yeah,
The
very
best way to
good.
live. TGIF.
Excited. Any other any other questions from the core team before we wrap up with Amy? Nope. All right. Well, Amy, really excited about this. I know you put a ton of work into it behind the scenes. So thank you. I know a lot of people are really excited about it. Appreciate it. I guess I do have one last question.
Sure.
Should we all be as afraid of GraphQL as they tell us we should be?
Oh no. I think GraphQL makes the world better. There's my hot take.
And you know what? I'm gonna take your hot take and I'm gonna notch it up a little bit. GraphQL out of the box with Redwood makes the world a whole lot better.
So, I mean, I'm going to push this even further. So this is going to
Oh
move
wow, we're
from
just
hot
go okay.
take to,
Yeah,
I mean, just, I'm going to keep
hotter,
bringing it
the
up. Yeah,
hottest.
yeah. The most hot. I mean, I'm in Nashville. We love Nashville hot chicken. This is like,
Yeah, so if you're gonna
top
go,
notch. Is that anytime now that I approach a project where it's like a REST API, I kind of, makes my gag reflexes go off a little bit. I'd much rather work with GraphQL. So, and the nice thing, I will say this, and this is part of the Learn with Redwood course, is that we are working with a REST API because it does look at the movie database. We pull that in, but we also are able to translate that into GraphQL and the services that Redwood provides. And it's so much easier and nicer to work with. And we talk about that in the lessons. And not only that, but you're taking a REST API and integrating it with the other GraphQL pieces within the application. So it's a beautiful thing.
I have nothing else to add. I have nothing else to add. Amy, thank you.
Thank you.
Please feel free to stick around. We'll bring Jack and Dan up now, and then we'll have some discussion time with them after. So you're welcome to join. Amy, always a pleasure. Thank you.
Thank you. Likewise.
All right. So for part 2 of March's Redwood Talks, a little bit of background here. Redwood, the very first deployment provider for Redwood was on Netlify, moved to Vercel as well, but we wanted full stack for the Jamstack was our initial deployment target and the story we wanted to tell. And very quickly, when you're working in full stack applications, you realize, man, what about all the persistent things we need to do? Lambdas are great when you need things to turn on and off, but sometimes you need background jobs running. You need cron. You need somehow to manage events, and we just never had a solution for that in serverless. There were a lot of things we could do when you were using Fastify and deploying on traditional architecture, but not in serverless, until we found this crazy company called Ingest. And I think, DT, has it been a couple months now that you found Ingest? We all got to meet you, introduced us. Jack and Dan, if you two want to come up now, we have been really excited behind the scenes. We have some experiments in progress. I'm not even sure if you've seen everything that DT and Josh Walker have been building and working on with Ingest, as well as Chris, who's here. We're really excited about it. And it's exciting for us to now get to tell the rest of the Redwood community what's been happening, and more importantly, what's coming because of Ingest and the integrations that we're working on right now with Redwood. So I'll hand it over to you two, but thank you. We've been looking and waiting for you for a long time. Where were you about 1.5 years, 2 years ago? That's all I've got.
We were building.
Jack, you're building. Hey, samesies.
We're here. We've arrived.
Okay.
Well, yeah, thank you, David. And thank you, Amy. That was awesome. I want to rewatch that again later. So yeah, thanks for the intro, the very nice, warm intro. I'm Dan. I'm a co-founder in Ingest. And at the high level, you might ask, what is Ingest? Ingest is a developer tool that enables you to run reliable background and scheduled functions and workflows on any platform or environment, right? From serverless to serverful, from Netlify to Vercel to Railway to a container. And we've been working with David, DT, and the Redwood team for a bit now. And we're excited to share a bit more about Ingest with the community. So Jack's here, and he's going to share a little bit about what we've been doing. And he's led the development of the Ingest TypeScript SDK. And he's also built the Redwood integration. So without further ado, Jack, take it away.
Thank you very much. Let me screen share. There we go. Cool. Yeah. So let's talk about serverless functions and serverless background functions. Because as Dave was alluding to, it's a rough area. So we're going to start out with a really boring but ubiquitous example of a welcome email. So let's say that we have an endpoint that signs up a user, and we're going to ignore the fact that it's wildly insecure right now. So it takes in an email, takes in a password, we're creating a user, and then we're returning that user ID. So new requirement comes in, you want to send a lovely welcome email to the user. So we're just going to whack that after we've actually created the user. So create the user, send the email. But the problem here is, what if sending that email fails? Then the request that our user is making to the API to sign up would also fail, and it would then appear as if they hadn't signed up at all, even though technically their user exists. So we could try and get around this. We could just not await sending the welcome email. So now, as soon as the user is created, for the user making the request, it returns immediately. But serverless specifically punishes this pattern a lot. As soon as that function has resolved with some data, like a user ID here, the runtime will usually die and your lovely email request goes with it. So our safest option then is to still await it, but use something like a .catch to just silently log the error somewhere. So this is great. We are still making the user now wait for this email to send, which is another problem. Maybe it's a really slow service. Maybe you're using something nice and fast. But if that does fail, sure, it logs, but how do I resend it? Where do I go to understand when and why this happened? And this problem only gets worse as your app grows. This is a really simple example, but this critical path of an API endpoint that signs up a user is suddenly muddied with loads of extra functionality that might work 99% of the time, but this is serverless. We're communicating over the network constantly. And as soon as that does go wrong, it's so hard to recover when it does inevitably fail. So serverless has this missing piece. It'd be perfect if we could move this work to the background in a safe, reliable way. Just say, send an email and figure that out for me. Serverless in general has it's so easy to write. DX is amazing, and you can hook into your front end like never ever before. And frameworks like Redwood, that, like we were just saying, pull in all of these amazing technologies, and then you couple those with platforms like Netlify and Vercel, and then use libraries like Zod and loads of fancy TypeScript stuff that have just made this ecosystem fantastic. And it's really easy then to create this type-safe performant code that focuses on business logic. You're not having to think at all about infrastructure. But still, pushing work to the background in these ecosystems is really, really, really hard. So almost everything serverless that is available is synchronous, and it's usually tied to a user-facing request because that's the most common thing that you see in the platforms. And it is true that some platforms have started to introduce background functions. There are Netlify background functions, which is awesome, but they're always a really small step to what you actually want in the real world. And in terms of things like crons, lots of platforms now for cron abstractions. I think everyone at some point has had that crazy cron job that runs at like 5 a.m. on a Tuesday, pulls your entire database, runs for 10 hours. It's not the way. Like, we've all seen the horrible thing, and it dies. How far did it get through? You have multiple crons reliant on each other then that are just spaced out by some arbitrary time. It's a bad time. So inevitably, when you do want something like this, you just can't do it in serverless. And as soon as you want to expand past those limitations, you have to eject from the lovely benefits that it gives you. Your team, or just yourself, you're learning AWS, you're learning Terraform. You're suddenly thinking about all the infrastructure that you haven't had to think about for so long, and migrating your entire product to a brand new place and maintaining that. So what if this was not a problem? What if we could write this separated, isolated, retriable code for background work and not have to dangerously pin it on to these critical user-facing API requests? And then instead of pinning to that functionality, we could just react to things. When the user signs up, do this thing over here, and not have to manage that process at all. And in Dreamland now, what if we could orchestrate these events over time, like days, weeks, and months, to create some really, really cool flows? But critically, maintaining that it's still as simple as writing a serverless function, which has so many fantastic ways to write them now. So this is exactly what ingest does. We provide you a platform that enables you to run asynchronous background work in any serverless environment. So you host your functions exactly where your API is. You trigger the work by sending events to us from anywhere, or we can trigger it on a cron schedule if you have repeatable work. And critically, we call you via HTTP. So it does not matter how or where your API is deployed. It could be Redwood on Netlify, it could be Deno on Deno Deploy, or Cloudflare Workers, or Next.js, or Express on Fly.io. It does not matter at all. Wherever you're receiving the most serverless benefits, you stay right there and we'll come to you. And then we can write this really cool, isolated, succinct code we were talking about to describe some really complex logic in one place. We're going to come back to examples like this, but the example on the right, I'm charging a user, waiting for an order to be picked up within 5 minutes. If it's not, try and refund them, and then notify them that their order's on the way otherwise. We're going to come back to these sort of examples because they're very exciting. Before we do that, I want to talk about events. I mentioned sending events just now, and a lot of us at Ingest have been in a position in our careers where we've really reaped the benefits of event-driven systems. And aside from background work, they can unlock so much functionality that we'll start to touch the surface of in a minute. And you can reap all of those same benefits with Ingest, but I want to be really explicit about what an event is and how we get to that dream. So if you've never worked for events before and you've probably just heard all the buzzwords, they're really, really, really simple. It's just a JSON object. It has a name and has some data. So this event right here, we can see a user is being created in the app, and we can see their email in the payload. That's it. That's all an event is. So the names of events tend to follow a certain format so that we can unlock some cool functionality further down the line, like wildcards, so you can listen to multiple events, but that's for later. And a great way to think about these events is just facts. So they're proof that something has happened in your system, and then you can dip into them at any time. And going back to the great benefits of serverless and all the frameworks we're seeing at the moment, a huge benefit of working with these is typing. So much TypeScript tooling is really, really enjoyable to use because of the typing they provide. And it is no different here. So with hundreds or thousands of these events flowing through your system every single day, you can hook that data into your IDE and automatically discover every single fact in your system. And the boundary between the client and server that I mentioned in a lot of frameworks being thinner and thinner, we can do the same for asynchronous work here too. So if you're a developer wanting to add a feature, you can immediately see everything at your disposal. You don't have to dig around the code base, try and find out specifically where something happening becomes a fact. And as we just saw, trying to pin things on at certain times, you just have immediate access to the end result, and you can do something with that. And this event-driven dream that I'm talking about is really easy to achieve now, because you just send events. When something becomes a fact, you just send an event. When a user is created, you just send an event. As soon as you have events to leverage, you can react to them in really, really cool, really powerful ways, which we'll get into. So to give us a head start as well, creating these events, we're going to look at quickly instrumenting a Redwood app. There's a GraphQL envelop plugin for this that you can use with Redwood or any Yoga server. So adding this plugin to our Redwood server is going to instrument GraphQL operations flowing through the app and give us automated events when either mutations or queries succeed, and then we can react to those events. And I'll reiterate, events are just JSON payloads. Sending them manually is really easy. You can just send them via Fetch or Postman, or use the ingest SDK, or use plugins like this just to get a head start and start filling your system with facts. So using it looks a little bit something like this. And aside from some boilerplate GraphQL instantiation on the right here, we're really only doing two small things. Number one, we are creating an ingest client using the SDK. Plugin is going to use to send events. And then we add the plugin to a plugins array. In Redwood, this would be extra plugins array. That's it. That's all we're doing. So this has loads of options for controlling how and when events are sent, and logging and picking up user context and automatically redacting data. There's loads and loads of really cool things in this plugin. But getting started with these sensible defaults is this easy. So next, we're going to boot up the ingest dev server. And you do that just using the command in the top right. I'm going to let this GIF play and hope that it loops. Local dev for serverless work, especially background asynchronous serverless work, is often not great. Front ends is easy, right? You can just boot up a website and start to have a look at it. But introspecting what's happened for this kind of work is really, really difficult. And if you've ever tried to set up local stack for AWS for anything even half complicated, I'm very sorry. And we want to change that. So you run this with that single command at the top, and it's going to find any local apps running ingest and then show us in real time all of the events flowing to and from those apps. And not only can we see the events, as you can see them coming in on the left there, but also we can perform step-by-step debugging of functions reacting to those events. So in this GIF on the left, we're seeing the events. In the middle, we're seeing the selected events payload and some functions that are running because of that. And then on the right, we're seeing step-by-step details of that function's execution. So this is a lot, and there's a lot going on. So we're going to take a step back and see what a simple example looks like for a Redwood app that we've just instrumented. So we've got dev server running, we've instrumented our GraphQL API. Let's say our Redwood app is a shop, and a user has clicked a button to add an item to their cart, which hits a GraphQL mutation. So with the plugin, when that happens, we receive an event in our dev server. It'll look a little bit something like this if you haven't played with the default config, GraphQL/add cart item.mutation. And we can see some of the details of the GraphQL mutation and then the resulting output showing us that we've created a new cart item with an ID of 16 and then what the created app date is. So because this event is here and it's come into the server, we know that the mutation was successful. and that the user has successfully added an item to their cart. And the GraphQL code for the mutation for itself remains completely unchanged. No one's had to go in and manually add all of this stuff. We're not pinning anything on to any of these critical flows. And now that this fact is here, we can start building on it. So we can write a function that reacts to this in the background. Now, when you usually think about writing APIs day to day, there's a process of understanding when something should happen and therefore where it should happen. So in this instance, users add an item to their cart, therefore I want to do something. And I have to know where the user adding an item to their cart happens in code. And you have to go looking for the API endpoint that's hit and then have to dig through the code to try and understand where is most appropriate for your new code to sit in that endpoint. And then we're back to that original problem with the welcome email that we talked about at the beginning of it's unsafe and it's affecting the user's request. But once you're using these events and facts in your system, you no longer need to worry about the where. And you're just given the opportunity to write this clean, isolated code exactly as you would describe it. So for example, using the event we just saw, if I want to say when a user adds an item to their cart, send a message to the marketing team, this is what that would look like in ingest. We create an ingest function called marketing push. We just give it a name so it's easy to reason about in the UI, provide a trigger, and then a function to run when that trigger is received. So if I read the sentence out again, when a user adds an item to their cart, send a message to the marketing team. And if we open up the dev server this time and one of those events comes in, we see that it's triggered a function. So we can select this particular execution and see what ran as a result. And from my screenshot, it looks like it went well. We can see the event payload and that our step successfully ran, and it's returned some data about the message that is sent. So we've got a message ID of 123, looks like. So already with this really small block of code, we've solved a huge problem. Our background work is now outside the critical path, so it never ever affects the safety or the speed of a user's request. And as a developer, I can react to something happening with a really small amount of code. I don't have any extra infrastructure. I need no prior knowledge of how an item is actually added to a cart, and I don't have to know or ever change that code. And if this fails, we'll retry it for you too. You can customize how many retries you want. We'll exponentially back off to be a little bit safer. And there are loads of controls, concurrency controls even, to ensure you're not rate limited by external APIs or exhausting other serverless limitations that you might have for other products that you're using. So right now, we can react to any fact that the app is producing really easily. And I could add another one of those functions, and that would fan out to those two places, and those two functions would listen at the same time in the background. But earlier I said we could also orchestrate these facts to create functionality that follows a sort of timeline. So I also talked earlier about being able to write code as you would explain it, and we'll do that again here. And we'll try and make a simple cart abandonment flow. And this is really getting into some of the power you unlock as soon as you're using just that base feature set of ingest. So let's say when a user adds an item to their cart, wait to see if they check out within an hour. And if they don't, send them an email. So this is how it would look in ingest. When a user adds an item to their cart, you can see the event at the top. We're going to run the wait for event function to see if that order completed event comes in within an hour. And if it doesn't, we send them an email. There's some fancier stuff going on in this code snippet that we're really proud of. This isn't run synchronously. Internally, ingest is going to treat this as a step function and run it piece by piece. And you can see the step argument in the like function definition above. So anything that uses that tooling, so run and wait for event there, gets its own individual retries. And there's loads of different tools in there for waiting time or orchestrating events together or running code. And even though you're defining this in a single easy to pass function, ingest is going to execute it when the event comes in, see that you want to wait for that other event, pause the function ending the execution, and then later resume it with a brand new request when we see that event, or in this case, if we don't within a certain timeout. And then your function decides what to do next, in this case, optionally sending an email. So serverless platforms really often have these request timeout limits, usually around 10 to 60 seconds. So doing this kind of thing in process isn't really viable. And even if you were to do this kind of thing in a serverful environment where it's possible, you're no longer accounting for if your server goes down or you have an update. You just have a deployment and they're rolling. So with ingest executing this one piece at a time in very small executions, and being able to continuously pause and resume your function as data is received, you can run these flows to safely span days, weeks, or months with a really, really tiny amount of code. And again, I want to stress these are just promises for you. So internally, ingest treats these as step functions and does some really cool stuff under the hood. But to you, they're just promises, and you can do anything that you can do in the JavaScript ecosystem. So you could take an action based on whether a user added friends or created a post first by using the wait for event tool with a promise.race. As we're seeing here, if they've added a friend first, we send them an email to say, hey, make sure to create a post as well. You could split a huge task into multiple long-running parallel requests and then pull everything together at the end to do something with that result, just using promise.all. We see a lot of people doing this with AI at the moment because they have very, very long request times. And because we're using this tooling, each of these calls will be run in parallel with their own execution, but also have their own individual retries should something go wrong. In that example with the chunking videos we've got on the right, if that's 100 chunks and one of them has a little bit of a wobble, maybe the external service is down briefly, we'll retry it, we'll fix it up, and your function will never know. Every call is much more durable and reliable is the point. Or you can just do silly things like sleep for really long periods of time, which on face value, I always think is just a really cool thing to do, but does actually prove quite useful sometimes. So the aim of ingest is, to make all of this background work possible in a serverless environment and make any platform you're on, be able to make those background functions reliable and durable, and make sure it's easy to write some like super easy code and some pretty amazing functionality with very little effort. And we want to fill that missing piece of serverless that's still causing people to have to migrate to long-running services and platforms like AWS or GCP, when this is the only reason they're doing so, and they lose all of the benefits they're reaping elsewhere. And what I've shown here today in some of the examples is really just scratching the surface of what's possible with these tools and the different kinds of patterns and flows that you can create. And yeah, I still can't wait to see how the Redwood community uses them to create some awesome things. So it's ingest with 2 N's, which I think is worth mentioning. It makes it much easier to Google. And there's some links to docs and the GitHub if you want to go take a look. And yeah, question time.
Oh boy, I think we got some questions. That's great. Let me just tie in a couple things that we're really excited about. Right, it's serverless first, but it can go server full or back again without any code re-architecture. Right, you don't have to go back and fix your logic. You don't have to change things, which is exactly what Redwood does. Right, so Redwood allows you to go serverless first. If you want to migrate. You don't have to refactor your code. You set up your new deployment provider, which by the way is built in, and back again. And could do that with ingest. We love that, right? So that was missing. We couldn't do that before. And you're exactly right. The story you told is why people very early on, and there's a lot of reasons, but like the most common one we saw is like, I just need persistence somewhere. I need to manage these things, and the only way I can do that is in a server full environment right now. So, and by the way, stuff's really, he's not kidding, this stuff's really hard. Secondly, this is an open source project. So ingest is a service which you could offer to get started with, or if you wanted to host these things your own or contribute to the open source project, it's all out there. Like the core is open source. We also really love that. That resonates very much with the heart of what Redwood is. And the community we're creating and the types of integration partners that we have. And so just those are highlights for me. And again, reasons why we are really excited to be working with you all. Okay, so DT is here, Chris is here, Josh is here. I'll let others from the core team chime in with questions as well. But I just wanted to tie those points together and say thank you. It was really great to have you do this presentation and share with the community what we're excited about. Rob Cameron.
Yo, yeah, thanks for that. Are these jobs like persisted in a database somewhere? So if ingest like goes away and then it starts back up, does it pick up where it left off? How does it?
Yeah, sure. So yeah, we basically manage the horror of managing all of this state for you. So when we're talking about things pausing and resuming, if you're running these things step by step, all of these things are going into a queue internally for us. We're going to keep trying, and we only, like any good queuing system, that gets removed from the queue when it's actually been done. The step functions go that little bit deeper then when we're saving state between runs so that we can kind of nicely resume the function. But yeah, if we had an outage or something, nothing of yours would be lost whatsoever. No.
Well, what if we were hosting it ourselves? Like, where is that queue?
Ooh.
If you were hosting it yourself, it would be on like you would host your own queue. So we would help you set it up like in your own cloud, and you would have like say a Redis back queue, but you'd also have a state store that would store logs of all your like actual functions that have ran. So you would get a history for days, weeks, months, whatever you wanted to set for the limit of that table, say. So it would be in your database. And so you would have the same kind of experience that you would with Ingest Cloud, where you can go back, weeks or months and see the logs of every single event every single function that ran. Does that answer the question?
Yeah, totally. Thanks.
A member of your team might be answering some questions on YouTube right now. Wanted to throw, which is great, but a couple of those questions were, is this effectively a serverless version of something like Sidekick or Celery? Just where does it compare? Like if people are already using X, they might consider using Ingest. Maybe help them a bit with that.
Yeah, exactly. I think that's a really good question because, we're used to often queues because that's how we've solved these types of asynchronous these problems in the past. So if you ingest seeks to kind of add an abstraction layer on top of that, so you don't have to worry about queues, you don't need to manage individual queues. So if you need to compare it to a similar thing like let's see, that was a Sidekick or Celery, yes, 100%. And what we aim to be is definitely a solution that you can simplify into the basic sense, saying, I'm going to send this event and I'm going to run some code based on this. So don't have to think about, there's workers that I'm running that are stateful, that are running for hours at a time, and what the CI/CD process is with that, or about, actually managing that queue yourself. Of course, you go the open source or self-hosted, you can go that path if you'd like. But in the platform approach, like, you don't need to worry about that. And that's definitely a great comparison. So if you're thinking about a queue or an event stream, or some sort of kind of any sort of message queue, whether it's SQS, Celery, Sidekick, any system like that, BullMQ, you can think of Ingest as a easy drop-in replacement for that. And the thing is, if it's not a one-to-one comparison, I just want to highlight, because not all of those things take care of retries the same way, concurrency, sleeps, waiting, coordinating with other events, step functions, all that durability. And a lot of them, don't work in a serverless environment. So that's where I think the comparison starts to fall off there. So we think of Ingest as much more than all what you can do with those platforms. Great. Was there another question in there? I'm sorry, I'm pulling it up myself.
Oh, you're good. I think Chris, go ahead and jump in as well. Are we okay to go a few minutes over? Does that work with for you, Dan and Jack? Okay.
Yeah.
Very good. Okay. We'll go a few. I'll cut off here pretty soon. But Chris and DT and Josh have been working on this. But Chris, if you want to jump in, I think we're working on new Redwood experiments. You can try these things out sooner than later, with some limitations and not fully integrating the framework. And Chris, I think I know you guys have been working on this. You're using it in TeamStream right now, Chris, but is there an experiment ready to go, or what? You mentioned you want to share something, and what's the current status? Oh, muted.
Whoops. Yeah, let me share screen here as I can find it. How do I share second display, or not display, but desktop too?
Is it popping up?
It's not showing the desktops, but that's fine. I'll just show you my main one and all. Is this? Can you see this site can't be found? Can't be reached?
Yep.
All right. Cool. Yeah. So I set up a little shortcut to help get you started with ingest. So if anybody wants to test this out today, you can do yarn DLX Redwood setup ingest. This will install the packages. So the ingest package, set up the ingest client to the server, the ingest client. So all this stuff is just, placeholder stuff that you can use, and then a hello world function. And then if you run Redwood dev, once this kicks up, it'll boot. So this is a brand new Redwood project. And if you run the ingest CLI, the dev server, that'll start up. And if we open that up, and now see the dev server here. And if we wanted to, we could send that first event. So I can send this. You'll see it pop up over here. It actually waited a second and it fired off, and you can see it waited a second, fired off hello world. If we want to do that same thing again, world, but this time we give it a name. I said Redwood. You'll see if I send this event, second event fires, or the hello world function, but you can now see that the body was sent with the name Redwood, and this actually says hello Redwood instead of hello world. So this can kind of just kickstart your experimentations if you want to take this for a spin. And then if you wanted to add the ingest plugin, all you would have to do is add that to your GraphQL. You just have to add that to your GraphQL function in the plugins, and pass in the client that we created for you.
Oh, that is awesome, Chris. That's the first time I'm seeing it.
Yeah, it was a little last minute thing, but I was like, I wanted to get this finished. I have plans. It's kind of just it's an initial Kickstarter, and then hopefully we can do the ingest plugin with it too, and just kind of keep building upon it and whatnot.
Yeah, that's great.
That's awesome. Chris, talk Redwood here just a second. This is one of the questions that I may have answered incorrectly. But where is the code living in terms of a Redwood architecture? Like where are you thinking about ingest? Where are you thinking about Redwood business logic, aka services? How does that play together, or are they pretty distinct?
Yeah, all your functions are going to live in this ingest folder. So you're going to add, if you wanted to add a new one, you'd create a new file, name it whatever you wanted, create the ingest function. So that now you have these functions. You import them into the server. So you add them here. So once you create a new one, you'd add there. That would be registered now with the ingest server. And you can actually see those if you go to, get out of the way, Zoom. If you go to if you have a regular Redwood project, it'll be at Redwood functions ingest. And you can actually see which functions are registered. So as you add more in that folder, they'll actually start showing up here. And then, everything just kind of lives on the API side. And if you wanted to, I have kind of a demo here, but all you'd have to do is, like, if you were in any service on your API side, you would just import the client, and then you just do ingest.send, and then the event name and whatever data you want. So that's kind of how it all lives. It just lives in one of your services. When you call that service, it'll fire off the event and run all your background jobs or whatever you want to do in those specific functions.
Amazing. But that's great. So simple.
Yeah. So if you had, like, I don't know, a service function over here, I don't know how many services is a new app, but if you had a service function, right, call send tweet or something, right, you could actually just import send tweet here, right, from the service, and then you would just call send tweet here. So technically this would
Oh.
schedule it 1 second after, right? So you would just send the tweet. So you'd wait 1 second after this event got called, and then it would just send the tweet from your service, just like that.
Yeah, and I think one of the key decisions that we did for the way, instead of having to deploy to yet another platform or like write something that feels like a separate directory to Redwood, I'm like, oh, now I'm writing a Lambda function, right? Is that you're writing this in your own code base. So it is designed to reuse your existing code, right? So you shouldn't have to do more. You should be able to bring in everything else that's in your Redwood project and then just drop it in and write all this functionality. So you shouldn't have to write something else that works in a different, like a Lambda environment. It's like just running in exactly where the rest of your Redwood API and your Redwood app is running. So exactly, Chris, thanks for showing that off. That was awesome. Appreciate that.
All right. Any other, I don't know if we saw any other questions from the queues. I think people are just excited about it. This is great. Very good. Well, thank you all. Chris, that's an awesome demo. I'm excited to see. I thought it would take longer. That was great. Some more to come on that too. So if you're watching this, we'll be packaging that up a little bit more, probably get information on our forums. Chris, you showed the repo there, but we'll make sure that information is available. And gentlemen, thank you for joining us. Amy, thank you for joining us as well. I love, so this is exactly the point of Redwood Talks, just the diversity of the ideas. This is what the Redwood Core Team is getting to experience on a daily, weekly basis, and getting to share all of this with the community is really exciting. So everything from design process to learning all these different technologies with Redwood, to taking Redwood and apparently giving superpowers, event-driven superpowers with ingest. So it's an exciting time to be a dev. Thank you all. This will be live on our channel, and we'll be watching comments from there. We'll share some links that we have, and we'll see you all, I don't know, in GitHub here pretty soon. So have a good day.
Bye.
Bye.
Thanks, everyone.